Okay, this video I think is now my third video for the chain rule applications lab. And we're actually now doing the applications, and I'm going to do in this video 61, 62, 63, and 64 if it doesn't get too long. And I've kind of graphed everything as well. So let's start with 61. It says find the equation of the tangent line to f of x equals x minus 1 cubed at the point where x equals 2. So before I start, I actually graphed this, and I'm going to go back to my first graph here. So here's x minus 1 cubed, and when x is 2, I've already done the work here. I see that the slope is 3, and I'm going to do the equation of the tangent line. So I already did this on the calculator, so I encourage that. So I now know that the equation of the tangent line is y equals 3x minus 5. Now, that will help me as I want to make sure as I go through everything that I'm doing it correctly. So first thing I'm going to do is get it set up. So I'm looking for the equation of the tangent line for this is 61, and this is my function. We already know what the answer is. So let's go through and do the work. Well, first of all, if I want to know the tangent line, I know I've got y minus y1 equals mx minus x1. So I need a point and a slope. And I know x is 2, so I know that the 2 is going to go here, but I have to find out, okay, what is the y going to be? So when I plug a 2 in there, I already kind of told you what it is. 2 minus 1 cubed is 1 cubed, so it's the point 2,1. So the 1's going to go here. So I already know the point that it's going to go through right there. Now I want to find the slope, which means I have to do the derivative. So I'm going to do f prime of x. And this, I'm using the chain rule, so this is a nice start. So I see the outside function is a power rule, so I'm going to do 3 times x minus 1 squared. Then I'm going to look inside, and I don't touch the inside, and look, and the derivative of x is 1, so that is the derivative. And now what I'm going to do is do f prime. I'm finding the slope at 1, okay? Excuse me, the slope at 2. I didn't mean to say that. Slope at 2. Okay, so when I put the 2 in there, I get 3 minus 2 minus 1 squared, or 3 times 1, or 3. So now the slope is 3. So the equation of the tangent line is going to be y minus 1 equals 3x minus 2. And if I go through and multiply this all out, I have 3x minus 6 plus 1, or y equals 3x minus 5. And that was what we found on the graph. So that one's kind of easy. This is on here as an application, but really when you did the chain rule, the derivative of the inside, or the baby, is 1. All right, the second one asks us to do the exact same thing, but now we've got some base e's in here, and this doesn't look as pretty. So they just wanted to know when x is 1, what is the equation of the tangent line? So I graphed this one as well. And this one I actually had to change. Look at my graph. I had to go up to 4,000 and down. I didn't have to do negative 4,000 because it was so steep. And look at my equation of my tangent line. It's ugly looking. The slope is so steep because it's almost straight up and down. It's 4,451. And it crosses, if I were going to let this cross, way down at negative 3,560. So that's kind of why I showed you this. Is this doesn't look as pretty. So I'm going to show you how to do the tangent line, and when something doesn't look this great as well. So the first thing I wanted to do on this was to plug the 1 in to see what because I know I've got to have a point. It's got to be 1 something, and I'm like, what is the something going to be? When I plug a 1 in here to find the point, so I've got y minus y1 equals m x minus x1. When I plug a 1 in to find the point, f of 1 is 6e to the 5 times 1 plus e to the negative 1 squared. So I have f of 1 actually comes out to be 6e to the 5th plus e to the negative 1. And I'm going to leave it that way for right now, but that's my y value. Okay, so that's my point right here is right here for the y value. I'm just going to leave it there for now because it's pretty ugly. All right, so there's my y value. Now I want to find the slope. So I'm going to go through and do the first derivative. So f prime of x is going to do, and so I'm going to do this first term. It's going to be base e, so it's you just rewrite the function, and then you have to take the derivative of the baby, which is 5x, so it's going to be times 5. And then I got to take the derivative of this next one, and I look at it, so I'm going to rewrite it e to the negative x squared. Then I have to take the derivative of the baby, so that's times a negative 2x. So I'm just going to rewrite this so it's a little bit nicer. So that's going to be 30 e to the 5x, okay, minus 2x e to the negative x squared. So there is our derivative. Now I want to plug in the 1 to find out what the slope would be there. So when I plug the 1 in, I have f prime of 1 is going to equal 30 e to the 5 times 1 minus 2 times 1 e to the negative 1 squared. So when I get done writing that, this isn't much prettier. It's 30, okay, e to the 5th minus 2 to the negative 1. 2e to the negative 1, sorry. Almost forget that. 2e to the negative 1. So that's my slope. I'm going to leave it that way. You can put it in your calculator to make sure it matches what we just found on our calculators. So when I do the tangent line, I've got y minus, and this is what I have, 6e to the 5th. This is my y value up from up above. E to the negative 1. Okay, so that's my y minus y1 equals, and then my slope is 30 e to the 5th minus 2e to the negative 1 times x minus 1. And you can move that over there and say y equals this. Which is not pretty. But if you were to go through and multiply this out, you will get what we found on our tangent line. It's 4,000. That's how steep this is. And it crosses very, very low on the x-axis. So there's our tangent line. Okay, so I like to have practice one of those so you have a base E and you can see it's not all going to be beautiful. All right, so the next one we're going to do is we have this graph y equals e to the negative x squared, and they want to find the interval for when it's concave down. So I can see from here to here, I did a sketch of it. I also graphed this, so this will be a lot nicer graphed. So it looks like it's concave down. It's going to be, I got these going by 1. So it looks like right here in the middle, it's going to be concave down. I just don't know what that interval would be, but it kind of helps me when I'm doing my work to see if I'm in the ballpark. So I just kind of did a sketch here. It's not as pretty, I know. Okay, so if I want concavity and I want to make sure it's concave down, that's when I do my f double prime of x has to be less than 0 or negative. All right. Now, they didn't ask me when this function was increasing or decreasing. I could ask you that. We've done one of those. So I usually have you set up an f prime bar and f double prime bar. This one I'm just going to do f double prime because all they asked us was for concavity. So we're going to find the first derivative because we need to find the second, but we're not going to use it. All right. So the first thing I'm going to do is the derivative and put it equal to 0. We've done a lot of these. So I have y prime, and I look at it, I have to rewrite it, e to the negative x squared, and then I have to take the derivative of the baby, so it's going to be negative 2x. So y prime equals negative 2x e to the negative x squared. I just rewrote that to make it look a little bit nicer. Okay. And when I go to do this one, I'm like, okay, that's nice to know, but I'm not using it for anything. I'm not going to put it equal to 0 or anything to find out when this function is increasing or decreasing. I'm just going to use this to find the second derivative. So I kind of set it up this way so it would be nice to do this. And I kind of look at it and say, I'm going to break it up this way where this is my f and my g, and I'm actually multiplying them together. So I set up my f and g. So f is negative 2x. So I'm going to use the product rule. F prime equals negative 2. g is e to the negative x squared. And g prime, we've done this, is going to be rewrite it times the derivative of the top. I'm kind of going in my graph. So g prime is going to be, for us right here, is negative 2 x e to the negative x squared. So we did that before, so we're kind of all set up. Now I'm going to do the second derivative here, and I'm going to do the product rule. F prime g, so I have negative 2e to the negative x squared plus f g prime, so that's going to turn positive because I have two negatives. So I have 4x squared e to the negative x squared. Now this is the one I want to put equal to 0, but before I do that, let's get this in factored form. So I look at it and see what do they have in common. So here's a term here and here's a term here. I can see that I can take out a 2 and e to the negative x squared. So y prime is, I actually took out the negative 2. I guess it doesn't matter. I could do one of each, but I'm going to take the negative 2 out and e to the negative x squared. So when I do that right here, that's a 2. I have a 1, and now the sign changes because 4 divided by negative 2 is negative, and I have a 2 and an x left. 2x squared left, excuse me. I'm going to put that equal to 0. Now, I got to fix that because I want to make sure you guys know it's a negative x squared. All right, so now I'm going to make my big T, if you will. Well, negative 2e to the negative x squared will never equal 0 because it's an exponential functions, and there's a horizontal tangent line at the x-axis, so that's just nice to know. So then I'm just focusing on this. Put this equal to 0, and then I start solving it. 2x squared equals 1. X squared equals 1/2. And I'm going to take the square root of both sides, but be careful when you do, you have to do your plus minus. So x is going to be plus minus radical 1/2. And you don't have to rationalize it. That's going to be perfectly fine. So that just tells me that negative radical 1/2 is here. It's a negative sign. Positive radical 1/2 is there. I don't really need the positive there, but now I got to test this, and you actually kind of go to the left and right. This is a number line. So because this is negative here, I'm going to go like -1, and I always go to the what's going on here. So if I put a -1 in here, this is always going to be positive, and then I put a -1 in here, all right, this is going to be, no, this is going to be negative, this is going to be a negative, so this turns positive here. Sorry about that. And in the middle, if I try a 0, this will make it negative, so that's going to be negative in here. So if this makes you uncomfortable, you can actually take this right here, plug it in your calculator, and just look at your slopes and to the left and right of that, and look at what the signs are, because you just want to know, are they positive or negative? And then I plug it in here to the right, like if I stick a 1 in here, so I have a negative times a negative, this turns positive. And the reason why it does, I didn't mean to confuse you, that this -2 is what's that made this. This first part was negative times negative, that's why it's positive. Here, if I put a 0 in here, this makes this positive times a negative because of that -2 in there. So now I know in between here it's concave down. So the answer would be between negative radical 1/2 to positive radical 1/2. This is where my function is concave down. Okay, so we just got one more to do. So let's do this one. This is 64. I did a little sketch. And on this one, they also want to know when it's concave down. So I actually did a graph of this one as well. And this one looks like it's concave down between 0 and 2, or on this side of it. It's just nice to know kind of what it looks like. And I use that to do my sketch. So they want to know the interval that it's concave down. So this one's the same thing. I'm going to make sure I do my second derivative and find out when it's less than 0 or negative. So the first thing we're going to do here is actually start doing the first derivative, but I don't have to do anything with it, but I need it for my second. And I notice that I have a product going on here. So I'm going to set up my f and g's here. So I got f is going to be x, f prime is 1, g is e to the negative x. And now this should be getting easier for you. I have to rewrite it, then take the derivative up here. So this is going to be negative 1 times this. So it's going to be negative e to the negative x. So this gets kind of easier, especially with base e. You can do that part. So now we're going to do the product rule. So f prime of x is going to be f prime g, so that's e to the negative x, plus f g prime, so that's going to be minus x e to the negative x because this was negative. Now what I want to do is factor this and get it in factored form so I can get it set for the second derivative, and I can see here's a term here, here's a term here. I'm going to take out e to the negative x. When I do, I have 1 minus x, and now this is in a better form for me to do my second derivative. Okay, so factored form really does help. So now I'm doing my second derivative, and this is my f and g for my second derivative. So I have f equals e to the negative x. F prime is going to be negative e to the negative x like we did above. G is 1 minus x. G prime is just going to be negative 1. So now I'm going to do my second derivative. So f double prime of x is going to be f prime g, so it's negative e to the negative x times 1 minus x, plus f g prime, so that's still negative, so it's going to be minus e to the negative x. And now I'm going to look at this to see if I can factor it. If you do this, it just makes life so much easier. So I have a term here and here. So f double prime of x, I'm going to factor out the negative e to the negative x. When I do, I just have a 1 minus x left here. And then I have a plus 1 because a negative divided by negative is going to be positive. So I have f double prime, that's a double prime, of x equals negative e to the negative x. And this is going to be 2 minus x, and put it equal to 0. So then I say negative e to the negative x equals 0. Never will. Thanks for playing. And this is 2 minus x equals 0. So x is going to equal 2. All right. So I'm actually going to come up on my graph here. I found x is 2. I'm going to do my f double prime. Whoops, sorry, I hit it. My f double prime bar. And at 2, about in here, I see where the change in concavity is happening. It's not perfect up, but it looks like right in here, 2 is going to be where it is. So I'm going to use this factored form that I have here to look at the plus and minuses. So I'm going to use this one right here and plug numbers to the left and right. So if I go to the left of 2, if I put 0 in there, this turns out to be 0 and a 0 there. So this is going to be negative because I have a negative going on here. And this is positive, so a negative times a positive. So I want to know when it's concave down. Oh, so concave down. So this is actually going to be positive, my fault. So this is going to be positive. It's concave up here. And then the concavity changes after 2. If I put a 3 here, this is a negative times a negative, and then this is going to be negative because this would be a negative times a positive, so that's negative. So then I can see that it is concave down when x is greater than 2, or you can say from 2 to infinity. And as I look at this, I think I just did this backwards. This should be negative right here. I'm sorry, guys. This should be negative and positive. I made a mistake. I hate doing this on the video, so let's just try this again. Let me try plugging that in. I must have done that too fast. So I think it's opposite what I just said. I want to know if I plug in a 0, this would be positive times a negative. This is negative. I was right the first time. I'm sorry. And then if I put like a 3 in here, this would be negative times a negative times a negative. This turns positive. So when is this concave down? It's when x is less than 2, and it's going to be from negative infinity up to 2. I'm sorry about that. So that's when that graph is concave down. So that concludes this video, and I hope it helped, except for that last mistake. I'm sorry about that. You have a great day.